Okay, so here we go. Let's look at that first. Let's look at scenario one with this. All right. Let's look at scenario one here. All right. So scenario one says this: we drop the brick, right? You don't need to see that again. So we drop the brick, and what did we have? Our change in potential energy, gravitational potential energy, was equal to minus 147 joules, which is equal to the negative change in kinetic energy, okay, which is equal to the change in kinetic energy is equal to uh, minus, I'm going to put that in parentheses, 1 half mv final squared minus 1 half mv naught squared. That's my change in kinetic energy, correct? And this equals negative 147 joules. Let's cancel the negatives. See, if you do it the calculus way, you don't get run into all these little algebraic tricks you have to do. But I think the algebra actually shows you what's going on physically. Cancel the negatives, so I wind up with 147 joules is equal to 1 half mv final squared minus 0, because v naught was equal to 0 when I dropped it, when the initial velocity was 0. Okay? Well, that's cool. Now I can find the velocity. But notice, there's scenario one. Scenario two is a little bit more different because we're going up at a constant speed. Once we get it going, we're going at a constant speed, then we're stopping. So there's all kinds of little changes in kinetic energy along the way. But for the most part, it's force times distance. Or you can also look at it this way. When this object was falling, Now, I just wanted to kind of do this little review on energy before we got into electric potential energy, because I think I just kind of rush into it, and students need a refresher on energy anyway. We physics teachers think everybody understands it. Well, if you've only had it once or twice, and it's been 4 weeks since you've looked at it, shit, there's no way you can remember that, right? So anyway, sorry about that. All right, so the object is falling. So the force is going this way, which is mg. Force of gravity is going this way, correct? So it's a negative force with a negative displacement. So the force is negative because of the drawing, and the displacement is going from 0 minus 3, which is also negative. So I've got minus mg times negative 3, which gives me again 147 joules positive, okay? Which we know that force times distance is equal to the change in kinetic energy, all right? There you go. All right, so now let's look at electric potential. All right, let's look at electric potential. All right, let's say here's my positive charge up here. Okay, and I've got a positive charge here. Somehow I've got it suspended for right now. Down here, and so my electric field is going this way. Now, notice I've got positive Q up here, negative Q down here, and the magnitudes of the two are the same on my parallel plane, okay? So the amount of charge, they're different. This is a positive Q, and that's a negative Q, okay? So let's say that the difference between the two is like this is 6 volts up here, and this is negative 6 volts down here. Now, charges are not volts. The charges are coulombs. And we'll get into that. So we got negative 12 down here, right? Or negative 6 down here. So, as this, now where does that proton want to go? Where does it want to go? It's going from positive 6 to negative 6, correct? So we write the change in voltage as this. Change in voltage is equal to negative 6 volts minus positive 6 volts, which equals negative 12 volts. That's the potential difference. The electric potential, not energy, but difference. All right? Let's say my positive charge, Q naught, was equal to 2.0 times 10 to the negative 6 coulombs. Okay, so it's 2 times 10 to the negative 6 microcoulombs. And you'd see that written like that. All right? Here's the deal. Here's the big idea. And then we'll get into the slides. All right? Here's the big idea of this whole thing. The energy, the change in the electric potential energy, which is also going to be in joules, the change in the electric potential energy, this is the change in the electric potential difference, which is also a voltage. Got to get the language right. This is the change in the electric potential energy is equal to Q times the change in voltage that it goes through. So Q is positive. So I've got positive 2.0 times 10 to the negative 6 coulombs times negative 12. It lost energy. Why? Because it wants to go that way. And it's going to gain kinetic. So its potential energy, its change in electric potential energy is equal to negative 12 times 10 to the negative 5 joules. It lost electric potential, so what did it gain? Kinetic energy. Let's say, so it gained kinetic as it went from that positive plate down to the, and smashed into the negative. I wonder how fast it went. Well, we'd have to know the mass. Let's say the mass of the thing was 1.5 times 10 to the negative 11 kilograms. Let's say that was the mass of the thing. Okay? And we know that the change in the electric potential energy is equal to the opposite change in the kinetic energy. Well, if this is negative, then the opposite of the change in kinetic energy is going to be positive. So Ke is equal to 1/2 mv final squared minus 0, because the initial velocity was 0, we're assuming. So can I solve for the velocity? Sure. Because I've got 1/2 m, again, we're going to go ahead and put this number in here, and we got negative 12 times 10 to the negative 5 joules here. Cancel the negatives. 1/2 times 1.5 times 10 to the negative 11 kilograms times v final squared is equal to 12 times 10 to the negative 5 joules. And so v final is equal to 224, multiply both sides by 2, times 10 to the negative 5 joules, divided by 1.5 times 10 to the negative 11 kilograms. Now, this is where I might get in trouble because and we take the square root of that. Let's just see what it is. Because I might have messed up and done something that was physically impossible to do. So let's take a look. because that voltage, it might have only worked on a proton or something like that, something really small. But anyway, so let's do this. So we've got 24 second e to the negative 5 divided by 1.5 second e to the negative 11. Oh no, we're fine. That equals that. Take the square root. Boom. 4,000 meters per second. That's not very fast. There you go. All right. Next, I'm going to show you one other thing before we get into the slides.